Today's topic, what we are going to discuss is very much interesting. It's a part of AMBA protocol. It's a APB. The topic which I am going to discuss now is on the screen. APB based verification test bench architecture using UVM, Universal Verification Method. Now what we are going to see is advanced peripheral bus. Advanced peripheral bus is just a part of AMBA protocol family, but it is used because it has a it consumes a very low power consumption because it has a low bandwidth, and it will be very much reduced interface complexity when compared to the other buses like Ethernet protocol and all, and it is also suitable for many applications wide for in around all the world. Let's now jump into the another slide. This is the base FSM, finite state machine of the AHP, which we are going to discuss now. There are three states: idle, setup, and access. In idle is a default state in which the select lines and the enable lines are low. So that if the data comes, there will be no transfer will be occurring. If you want a transfer, thus the transfer occurs, then it jumps to the setup state, in which the setup state, the select line will be high and the enable line will be low. If the select line is high and enable line is low, it just transfer the data to the access point. The select line will be high as well as the enable line will be high. That is the three possibilities. Where the ready port will be 0, which means low, or high to access, in which the transfer occurring or not occurring. So the proximity is 3. So if in access state, if a ready state is low, then it will be in the data will be in access state only. If a ready state is high and the data transfer is occurring, then it will jump into the setup state, which is a second state. If ready state is high as well as there is no data transfer, then directly jump into the default state, which is the idle state. This is the basic FSM of the AHP protocol. AHP is a part of the AMBA protocol, so to say. Then we can discuss about the block diagram. This is what I said in the previous slide. Select and P-select and P-enable is the two main ports. After that, the write port and the address port will be there. Then reset and clock for the transfer of data. The major the port is write data, in which the input of the APB slave is the write data and the output of the APB slave is the read data. Thus, we are continuing to UVM Testbench. The UVM Testbench architecture is totally a different form, which I can't explain fully in a single video, but I will try to manage that. There is a UVM Testbench in which I have created. Please see the cursor. The testbench which is in this line is UVM Testbench. Okay. Now we are going to interface the APB protocol, APB, and to the DUT. DUT is a design under test. We will discuss everything: APB sequencer, APB driver, monitor, agent, scoreboard, environment, base test, what is the test bench, everything in the next slide. Just wait. Now the components of the environment. Environment is please note the cursor. Environment is this box. Okay. What and all comes under this box is known as environment. APB environment. It's I told now what and all components comes under this box. The previous box is environment is driver, monitor, sequencer, etc. First of all, we can discuss about the agent. APB agent is together a verification components that are dealing with a specific what and all the DUT components that will create an agent. The monitor, it captures the information and the transactions which are placed in between the UVM test bench, and the sequencer is it encapsulates the sub components for the sequence communication with the driver. The driver is a communication with the sequencer, and the scoreboard which acts a main function to the to check whether the output of the test bench is correct to of the direct input. Then it's a test bench top module in which APB statement is interfaced and the clock is mentioned, and the UVM configure DB slash virtual APB if is the at the start of the simulation. The interface handle is setted and from the UVM database, and the test is run. This is the top module. The execution flow is very simple. In base test, just we need to instantiate the environment and the sequencer. At the end of the test case, we want to know the topology print from the debug is correct or wrong. Then APB environment is this instantiate the agent and the scoreboard, in which the execution of the output is right or wrong. It will say the agent is just an instantiated driver sequencer. In agent, a driver sequencer and monitor is instantiated. It's a normal 3 components which are all agents will have. As many agent we can have for the execution flow. Then this is the UVM topology, in which UVM desktop as environment, agent, in agent driver, respo port, sequence item port, monitor, agent, driver, monitor, sequencer. In sequencer, these items are there. Then scoreboard. So these are the UVM blocks. APB sequencer, APB item. The APB sequence is just a interface between the data exchange between the sequencer and the driver to send the sequence item. This is what written in system log. Then APB sequence item, the constraint are specified in the sequence in item class, which has a 32-bit data, write data as well as the address. The execution is of this APB driver. The next item from the sequencer assigned to the data interface is for transaction. The transaction is driving the data from to the scoreboard. This is the exact bus protocols. The simulation results of the APB part of the AMBA protocol is shown to you as the clock rises the clock for address 32-bit. After each clock there will be a delay and the enable rise. This represents the FSM which I have shown in that figure. This write the data as well as enable the data to this kind. When reset is high, when the reset is high and the data is written, the read data will be when the read data will be high, the write data will be high. When it is readed, it is written. This is what is shown in this waveform. Thanks for watching. Thanks a lot.